Welcome to this edition of Finance in 5 Minutes presented by Stratfield Solutions. Today we're going to be finding the nominal rate of interest using Microsoft Excel. And if you like this video, please give it a thumbs up and subscribe to our channel for more Excel and finance updates. So walking into this formula, what we're going to do here is we're going to take a look at using one of the pre-programmed Excel functions to derive the nominal rate of interest, also sometimes referred to as a stated rate. And we would be doing this if we were given an effective annual rate, also known as an EAR or EAR, and specific compounding periods. So we have another video that refers to how to take a nominal rate and convert it into an effective annual rate. But here what we're going to do is we're given an effective annual rate and we're then asked to use or to find a nominal rate to calculate a particular time value of money type of problem. You can do it by hand, takes a lot of steps, wouldn't recommend it, and Excel has a super easy formula/function to use. So a few tips and cautions when going through this calculation. Most important, you have to identify the current rate structure, whether that's an annual, semi-annual, what is the breakdown of the compounding periods, and again, that compounding frequency. Now, most of the time, the EAR is obviously stated in an annual term, so the rate structure isn't really going to be applicable here, but you do want to understand if it's a compounding rate frequency that's something other than an annual basis. And so again, the EAR, effective annual rate, obviously that will be in a yearly type of period expression, but you do need to know what the compounding frequency is that it's being asked to convert into. Finally, when you're putting in information into Excel, you want to make sure that you have the interest rate listed as a percentage using the percentage symbol or as a decimal when you're putting it into Excel. So this is very easy syntax to write the formula in Excel. So it literally is nominal, and then after the open parentheses, it's effect rate, comma, N per EY or N per E. So the effective rate is the EAR rate of interest. Again, this would be something given to you in a problem. They'd say the effective annual rate is such and such a percent. And then the number of periods, N per EY, is that number of times in the period that the interest is compounded. So we'll go through an example here in Excel in a second, and I'll show you a couple of different compounding periods that you would be looking at to convert the EAR into. So let's jump into Excel and take a look. So here we are in Microsoft Excel. I've laid out a very basic problem that might get asked. What is the nominal rate of interest for an investment that pays an 8% EAR, but with compounding, that is? And we'll go through these 4 different types of compounding periods. So again, the given rate we put up here as our 8%. That was provided to us in the problem. And then the compounding periods per year, let's just start with 1 for the annual interest rate. So again, as we saw in the PowerPoint, the format will be equals nominal. You can see that it starts to provide the nominal function for us here. If I click on it, the effect rate, again, 8%, comma, the number of periods it's going to compound during the year would be just 1. And lo and behold, obviously, the nominal rate will be equal to the effective rate if the compounding period is exactly the same. So I'm just going to put this over here for our reference. Now, if I want to change this to a semi-annual, I will have 2 compounding periods per year. So you can see that the formula has updated to 7.85. Now notice that this is still being expressed in annual terms. So while this is the semi-annual rate, if you were using it in a calculation, you would need to divide this by 2 when putting it into such formulas as PV or FV. So I'll put it over here for the reference, but again, keep in mind that this is always expressed here in this column as an annual percentage. And of course, if I go to quarterly, we'll have 4, and you can see that as expected, the interest rate as expressed on a nominal basis is dropping. So if I go to 365, it will be the lowest of these values, and you can see how that's going to be presented. So again, you would divide this by 365, divide this by 4, such on and so forth, to put on into your PV and FV formulas. So that's all there is to the nominal effective rate conversion in Microsoft Excel. And again, if you like this video, please give it a thumbs up and subscribe to us at Stratfield Solutions for more Excel and finance tips. Have a good one.